Hello students, I Mrs. Madhavi Mhatre welcome you all in the next lecture of Mathematics 1. We are studying chapter number 2, that is real numbers. In that we are solving practice set 2.3. I hope all of you must be ready with your textbook, notebook and pen so that you can write down the solutions of the problems. Okay, so let's go further in practice set 2.3. Question number 5 here. We have completed up to question number 4. Now question number 5. Compare the following pairs of surds. In the comparison of surds, we have studied that we can compare two surds if their order is same. That means the radicands, the number inside the radical sign, they can be compared if their order is same. Also, the second thing is what? The surds, they must be in the pure form. That means what? They should not be in the simplest form. This irrational part we have to take inside. Or the second method we have seen, we can square both the surds and then we can compare. Okay, this we have seen that after squaring also the order does not change. If a is greater than b, then a square is greater than b square. So either we can square them or we can express them in the pure form. We have to convert it to the pure form. That means only the irrational part. Okay, it should not contain two parts like that. Okay, then I told you that you can use any method. Okay, now let us see first one here. 7 root 2 and 5 root 3. So according to the first method, we are going to take this 7 and 5 inside the root sign. So we can write 7 as root 49 into root 2 as it is. And the second surd here, 5 we will write as root 25 into root 3 as it is. Okay. Now here 49 into 2, we can do this multiplication here since the order is same. And here we will get root 98 and here we will get root 75. Now see, the order of the surd is same, that is 2, and that is why we can compare radicands. What we can observe is 98 is greater than 75. Therefore, we can say that the first surd, that is 7 root 2, is greater than the second one, that is 5 root 3. Okay, this is first method. You can use the second method where we are going to square both these surds. Okay, so here 7 root 2 square and 5 root 3 square, in between put comma. Also don't forget to write these surds in bracket, because if you are not writing the bracket then the meaning changes. We have to square both the parts, rational as well as irrational. So here 7 square is 49 and root 2 square is 2. So 49 into 2 we are going to get 98. Similarly here 5 square is 25 and root 3 square is 3. So 25 into 3 is 75. And easily we can understand here 98 is greater than 75. Therefore, the first surd is greater than the second one. Okay, the symbol remains same. So if you feel that this is easier, then you can go for first method, or if you feel that the second one is easier, you can go for the second one. Okay, you can solve it by either method. Now second one is very easy. Root 247 and root 274. See, already they are in the pure form. So we don't have to convert them. The order is same. So easily you can compare the radicands here. 274 is greater than 247. Therefore the second surd is greater than the first one. Or first surd is less than the second one. Okay. This way you can solve it. Now let us go further. Similarly, third, fourth and fifth also you can solve. See, this is already here in the pure form. So you only need to convert this. Okay, so when you will convert it here. This 2 will go inside as 4 and 4 sevens are 28. You will get root 28 both the places. That means these two surds are equal. So these are easy sums. Here also you can do same as the first one. Okay. See here in this case the first method is more easier, or second also will do, but converting this into the pure form will give you the answer. For fourth one, you follow the same method as the first one. Now let's see fifth one. 4 root 42 and 9 root 2. Okay. So first of all, let us write down these 4 as root 16 into root 42, and 9 we will write as root 81. See, while writing inside this radical sign or while writing in the square root sign, you have to square this number. Okay. So 9 is nothing but what? Root 81 into root 2 as it is. So when you will multiply, that time you will get numbers like this. 16 into 42. See, 16 2s are 32, 3 carried, and 16 4s are 64 plus 3, that is 67. So here the multiplication is root 672, and here 81 into 2 is 162. So now the order is same, so we can compare the radicands. We can clearly see here that 672 is greater than 162. That is why we can say that the first surd is greater than the second one. Okay. If you wish, you can solve it by the second method also. I have solved it only by the first method. So you can use this method. You can square this first one, 4 into root 2 the whole square and 9 into root 2 the whole square, and afterwards the same numbers you are going to get. Here you will get 672 and here you will get 162, which you can compare, and you can say that the first surd is greater than the second one. Okay. Similarly, you can solve fifth and sixth and seven also. Okay. Here this 9, here you don't have the irrational part. So you can write this as root 81, and this 5 if you take inside, it will go inside as 25, and here you will get root 75. So root 75 and root 81, it is very clear that 81 is greater than 75. So here 9 is greater than 5 root 3. Okay, so this way you can decide. Now let us see question number 6. Simplify. So this question depends on the operations on surds. There what we have seen is addition and subtraction is possible only in case of like surds. So if we want to add or subtract the surds, they should be like. That means here also we should express the surds into the simplest form, and then we should solve it. Okay. So let us do it now. Here I am taking the first one, which is very easy, 5 root 3 and 8 root 3. Already they are in simplest form, and what we can observe is they are like surds, because we can see that the irrational part root 3 is same. So in that case what we are going to do is this irrational part we are going to take out common, and inside the bracket we are going to add rational part. Okay. So we have 5 plus 8 outside the bracket root 3. Like we are doing 5x plus 8x. That time we are writing it as 5 plus 8 and outside the bracket x. X is common. So here 5 plus 8 is 13. So your answer is 13 root 3. Okay, so it is very easy if the surds are like. But every time they are not like you can observe here the second sum here, that 9 root 5 and 4 root 5. These two are like surds. But this is in the present form, it is not like to these two surds. So we have to convert it to the simplest form. Okay. So this 125 you can convert as 5 root 5, because 125 you can write as 5 into 5 into 5 or 25 into 5. So here you will get 5 root 5 for 125, and then these three are like surds. And then you can add 9 plus 5 minus 4. Okay. So or 9 minus 4 plus 5. So 9 minus 4 is 5, and 5 plus 5 is 10 root 5 is the answer of this. So do it as homework, okay? Third one now I am solving for you. 7 root 48 minus root 27 and minus root 3. So here also what we can observe is these surds are not like. Here root 3 is in its simplest form. So make use of this. Okay, use the common sense that since root 3 is present here, here also we are going to get root 3 somewhere. That means these two numbers we should divide by 3 and check whether the second factor is a perfect square or what. Like 48, if we divide by 3, we will get 16, which is a perfect square. So 48 we can write as 16 into 3. Similarly, 27 we can write as 9 into 3. 9 is a perfect square. Okay. So let us simplify it now. So 7 is written as it is outside the radical sign, and inside the radical sign or inside the square root sign, 48 is expressed as 16 into 3. Then minus sign as it is. Again square root sign, 27 is written as 9 into 3 and minus root 3 as it is because it is in simplest form. We cannot simplify it further. Now see this root 16 we can write as 4. So here 48 we can express as 4 root 3. Similarly root 9 we can write as 3. So 27 we can write as 3 root 3. Okay. So this 7 as it is and 48 which is written as 16 into 3 further we can write as 4 root 3. And for 27 which we have written under root 9 into 3 that we can write as 3 root 3. And here we have minus root 3 as it is. Now see 7 into 4, this rational part we can multiply. So that will be 28. Okay. So here we will get the next step as 28 root 3 minus 3 root 3 minus root 3. Now see these all three are like surds and we can add and subtract them. So let us take out root 3 common and inside the bracket we will get 28 minus 3 minus 1, that means minus 4 here. 28 minus 4, the answer is 24 root 3. Okay, so this way you can simplify. This second step is most important. You should know how to express this pure surd in the simplest form. Converting it to the simplest form is most important thing here. As soon as you get the like surds, then adding and subtracting is very easy. Okay. Now let's go further. I hope you must have copied it. If you have not copied it, please pause the video, copy and then go further. Okay. Next one, fourth one. Root 7 minus 3 upon 5 root 7 plus 2 root 7. So here if we observe the irrational part of these three surds, we can clearly understand that the irrational part is same and therefore these three are like surds. We don't have to think of the rational part. So here we can take out root 7 common and inside the bracket we can write down the rational part. Here nothing is present means 1 is present. So what we can write down inside the bracket? 1 minus 3 upon 5 plus 2 bracket complete and outside the bracket root 7. Okay, now here we have one fraction and then to add or subtract it, you know that all the three numbers they should have equal denominator. So here we want denominator 5, so we have to multiply both the places by 5. And here also we want 5, so here also we have to multiply. So this 1 we can write as 5 upon 5 and 2 we can write as 10 upon 5. Okay, and then we can simply add the numerators as 5 minus 3 plus 10 totally upon 5, a common denominator of all three fractions. See, 1 is converted to 5 upon 5, 2 is converted to 10 upon 5 and minus 3 upon 5 as it is. Okay, so 5 minus 3 is 2 and 2 plus 10 is 12 upon 5. Root 7 is our answer. Okay. So this way we can simplify the surds. So we can add or subtract the surds if they are like surds, and for that purpose you have to express them in the simplest form, or you have to convert them to like surds, and then only you can take out common the irrational part and you can add or subtract the rational part. Okay. Now let's go further towards the next question. Question number 7. Multiply and write the answers in the simplest form. Okay. So here you know that we can multiply two surds, or we can multiply the radicands of the surds if their order is same. So here everywhere order is same because we are studying only quadratic surds. So there is no question of equalizing the order or making the order same. Already it is same only. So multiplication here is very easy. So let us start now. First one, 3 root 12 into root 18. Now see, this sum you can solve in two different ways. First way is what? You can multiply rational part into rational part, that is 3 into 1 you will write 3, and irrational part into irrational part you can multiply. That means under root you can multiply 12 and 18 and then you can convert in the simplest form. Or the second method is what? You can convert first in simplest form and then you can multiply. So this is much more convenient because when you are multiplying the radicands directly, you are getting a very big number and then factorization may be difficult. So instead, here only you express in the simplest form first and then multiply. So 12 we can write as 4 into 3. So root 12 we will express as root 4 into 3. Again into sign, and root 18 we can express as root 9 into 2. 9 2s are 18, 9 is a perfect square. Always keep in mind that one factor should be a perfect square. You have to find the factors in such a way that one factor should be a perfect square. Now see, this 4 will come out as 2. So root 12 we can express as 2 root 3. And root 18 we can express as 3 root 2 because 9 is a perfect square of 3. So see, 3 into 2 root 3. This 4 is converted to 2. And here root 9 is converted. Inside the root sign 9 is there. So 9 is converted to 3 and root 2 as it is. Now we have to multiply rational parts separately and irrational parts separately. So 3 into 2, 6. 6 into 3, 18. And here root 3 into root 2, we are going to get root 6. See, multiply the rational parts separately and irrational parts separately. So 3 into 2, 6. 6 3s are 18. And here you will get root 6. So your answer is 18 root 6. Okay, so multiplying is very easy, but here, as I have said, you have to convert it into the simplest form first and then you need to multiply. Now here, multiplication of two irrational numbers turn out to be irrational only. But sometimes what we find is multiplication of two irrational number is a rational number. In solved examples, we have seen that. Okay, now let us go further. This third and fourth you can solve similar to this one. Okay, see here root 12 you have the simplified form here, and root 15 you cannot simplify. So root 12 you can write as 2 root 3. So here you will get 6 root 3, correct? And here 7 root 15, and then you have to multiply. Okay. Similarly, you will solve third one. This root 8 you will express as 2 root 2 because 8 is nothing but 4 into 2. So this is under root 4 into 2. 4 is a perfect square of 2. So root 8 you can write as 2 root 2. So here you will get 6 root 2 into root 5 and then you can multiply it. Okay. Now let us discuss this fourth one, which is little bit different. Here 5 root 8 into 2 root 8. See, here 5 into 2 if we do, we are going to get 10. And root 8 into root 8, we will multiply separately. Okay. So rational part is multiplied and irrational part is multiplied. So 5 into 2 is 10 and root 8 into root 8 is 8. Now here you will think that why this root 8 is not simplified. It is not simplified because here we can see that they are like surds. And then root 8 into root 8 is going to give us 8. So why to unnecessarily extend it? So if you have same irrational part, then don't simplify. Simply you can multiply it 2 times and you're going to get the same number. Okay. So 10 into 8 is 80. So what we found here is the multiplication of two irrational numbers is a rational number. In case of addition and subtraction, the addition or subtraction of irrational numbers is irrational number only. But that is not true in case of multiplication and division. The multiplication and division of two irrational numbers can be irrational or it can be rational, as we can see both the examples here. Okay, so copy down this sum number 1 and sum number 4, and similarly you solve second and third as homework. Okay, now let's go further. Question number 8. Divide and write the answer in the simplest form. Okay, so the question number 6 was on addition and subtraction. Question number 7 was on multiplication, and question number 8 is of division. So what we know is when we divide two numbers, a divided by b, suppose, then we can write it as a upon b. Okay, so this is your dividend and this is your divisor. So that dividend comes in numerator and divisor comes in denominator. Okay, that way we can express in the numerator denominator form or in the fraction form. So let us do it. First one, root 98 divided by root 2. So that we will express in the fraction form, but while writing we will write them under the same root. This step is very important because we are cancelling 98 with 2, but if we write root 98 upon root 2 separately, it is not possible for us to cancel. It is not allowed. We can cancel these numbers if they are in the same radical sign. So root 98 divided by root 2 we can write as under root 98 upon 2. Now see, 98 is divisible by 2. 98 divided by 2 you are going to get 49. But 49 is a perfect square. You know that root 49 is nothing but 7, a rational number. So once again let's prove that the division of two irrational numbers can be a rational number. Okay. Now let us go further. Question number 2 is similar to first one, and question number 3 also is very much similar. So you have to do this as homework. Actually all the questions are like, but still I am solving question number 4. So second and third, which are more easier. Here also you can write down 125 divided by 50, and you know that these both the numbers are divisible by 25, and you will get the answer. Similarly here 54 upon 27, you know that 27 2s are 54, so here your answer will be root 2. Now let us see this. Square root of 310 divided by square root of 5. So let us write down this step, that we will write it under the radical sign, that root 310 divided by 5. Okay, and the division is 62. 5 6 are 30. 1 is left out, then 10, 5 2s are 10. So root 62 is the answer. Here root 62 we cannot simplify further. If you divide 62 by 2, you are going to get 31, which is a prime number. So 62 don't have a factor which is a perfect square. So this answer is as it is. Got it? So this way you can add, subtract, multiply and divides the surd. Okay, in case of addition and subtraction here, the surds must be like surds. That means what? Their order also should be same and the radicand inside should be same, like root 3 or root 2. But for multiplication and division, if they are not like, then also it will do. Only the condition is what? Their order should be same. Like here, square root of 98 divided by cube root of 2 is not possible. Why? Because the order is different. Here the order should be same. This is important in case of multiplication and division. Okay. So I hope you must have understood this. Now question number 9. Rationalize the denominator. We have seen in the previous lecture that we are rationalizing the denominator because the rational denominator makes the things easier. And while rationalizing this, we have to think of the rationalizing factor. And only we are going to think of denominator. Okay, so let us see question number 1 here. 3 upon root 5. Okay. So we don't want rational number here in the denominator. So think of rationalizing factor of root 5. So it is root 5 again. So we have to multiply and divide by root 5. So write down the given surd as it is 3 upon root 5 into root 5 into root 5. Okay. We have to multiply both the places, numerator as well as denominator, so that the original surd or original number is not disturbed. Now here 3 into root 5 will give us 3 root 5 and root 5 into root 5 is 5, which is a rational number. Okay, so that way we have rationalized the denominator. It's very easy. Similarly, you can do for second one. Here you have root 14. So you can multiply and divide by root 14. And then you will get root 14 upon 14. Okay, very easy. Similarly, question number 3, you have to multiply and divide by root 7. And then you will get it. Now let us see fourth one, where we have a mixed surd, or you can say the simplest form here. Here or everywhere the pure form was there. Now here we have a mixed surd where we have rational part and irrational part. Now this 9 root 3 we have to rationalize. Okay. Now here when we were having root 5, we multiplied by root 5 and divided by root 5. So here you can multiply and divide by 9 root 3 also. But as I have said, you have to think of the simplest factor, and for that purpose only observe the irrational part. Forget the rational part. So here irrational part is what? Root 3. And you find the rationalizing factor of that irrational part only. That means for root 3 only we have to rationalize. So here we need to multiply and divide by root 3. Don't multiply and divide by 9 root 3 because we have to think of the simplest rationalizing factor. Okay. So now when we will multiply here 6 into root 3, 6 root 3, and here 9 into root 3 will give you 3. Okay, so 9 into 3. But now see, this 3 will get cancelled with this 6. We can cancel 3 ones are 3 and 3 twos are 6. So our answer is 2 root 3 upon 9. Because we have to express the answer in the simplest form always. Okay, so in this way it is very easy. Now question number 5 is similar to the first one. Here also you have to multiply and divide by root 3 and you are going to get the answer. Okay. So in this way we can rationalize the denominator. Now the remaining things, the remaining concept of the surds we will, that is conjugate pair, we are going to learn about, that we will see in next lecture. Okay. So all of you please complete practice set 2.3 and do the homework. Okay, students, so today I am stopping here. We will meet in next lecture. Till that you stay home, stay safe, take care of yourself. Thank you students.